Assalamualaikum warahmatullahi wabarakatuh. For today's session, I would like to discuss on analysis of beam using stiffness method. As you can see in screen right now, we have an indeterminate beam with A, B, C, D. There are 3 elements, and this beam is subjected to various types of loading. Okay, what we need to do is number 1, calculate non-zero degree of freedom. Number 2, calculate unknown reactions at all supports. And number 3, we need to draw shear force diagram and bending moment diagram. Okay, so we will start this. We will start this with we need to sketch this according to unconstrained and constrained. Unconstrained and constrained. There are four nodes. Four nodes A, B, C, D. A, B, C, D. One for unconstrained and another one for constrained. So at A, it is fixed support, and remember the degree of freedom for beam. We has to count 2 degree of freedom at each node in Y and Z direction, and the reaction at the support that we get from a beam is actually the degree of freedom in the constraint system. So what we get is like this: Y and Z, Y at C, Y at D, means that there are 5. So here there are 5 degree of freedom. In constraint system represent 5 unknown reaction. Okay, represent 5 unknown reaction. Why it is 5? Conventionally, we know that at A is fixed, so there are 3. However, in stiffness matrix method, we only count degree of freedom in Y and Z direction, because Y representing axial deformation and axial force, the value is 0. So we don't count that one. Okay, so move to this. So in unconstrained, we must put 2. We must put 2. We have to make sure that there are 2 degree of freedom at each node. So 5 has been put under constraint system, and we have to put another 3, because in total there are 8, because 4 times 2 is 8. So we have to put the remaining 3 to complete the degree of freedom. So we have to put Z at B, Z at C, Z at D. Okay, so when we label, we need to label start from unconstrained. So in unconstrained, there are 3 degree of freedom, represent 3 unknown displacement. Okay, for constraint we call this as 0 degree of freedom. So in unconstrained, we also put this as non-zero, because the condition is always in opposite, non-zero and 0. 0 degree of freedom means the okay, label first. 1, 2, 3, 4, 5, 6, 7, 8 means D4. D5, D6, D7, D8. This is all 0. This is all 0. This is what this statement means. 0 degree of freedom. So non-zero degree of freedom is actually belong to unconstrained. So this is equal. Okay. So in unconstrained unknown displacement is actually non-zero degree of freedom. The label is D1, D2 and D3. Okay. So back to the question. Question number 1. Calculate a non-zero degree of freedom. Calculate non-zero degree of freedom means we need to calculate D1, D2 and D3. And number 2. Calculate unknown reactions at all support means that we have to calculate Q. Q in constraint system means we need to calculate Q4, Q5, Q6, Q7 and Q8. Okay, lastly, we need to draw the shear force and bending moment diagram. Okay, so we will start with identifying or establish element global stiffness matrices. So we need to refer to the appendix for stiffness method. We need to refer to the appendix and we calculate the value for K1. Okay, let's say this is this one. This is 2 meter, 2 meter, 5 meter. This one is 3 meter, 2 meter. Okay, so the length for member AB is 4. So we put into the formula and the answer is okay, 1 it is 0.188, 0.375, negative 0.188, 0.3751, negative 0.375, 0.5, 0.188, negative 0.375, and 1. Okay, I believe every one of you understand how we get the K1, and what most important is the level of degree of freedom outside the matrix. Okay, we need to refer to this one. We know that element number 1 is member AB. At near it is 4, 5. At far it is 6, 1. So we should label as 4, 5, 6, 1. So we should label as 4, 5, 6, 1. 4, 5, 6, 1. So this is 4, 5, 6, and 1. Alright, so this is the K for element number 1. Okay, we will do the same for K2 and K3. Okay, so this is for K2. So I have put all the value inside the matrix. So remember, we need to label the degree of freedom, and we need to again refer to this. For element number 2, it is member BC, the near node. The label for DOF is 6, 1, and the label for far is 7, 2. So it is 6172. 6172. Okay, now I want to continue calculate K3. Okay, this is K3. Since K3 has the same length with element number 2 or member BC, so we will get the value which is equal to K2. However, the degree of freedom label is different. Okay, so based on the labeling in the diagram that we sketched at the early of analysis for member CD, near will be 7.2 and far will be 8.3. So we have to put this label in K, 7.2, 8.3. 7283. Okay, so this is how we establish element global stiffness matrices K1, K2 and K3. Okay, we will continue with establish equivalent element nodal forces. Establish element global stiffness matrices and establish equivalent element nodal forces. Establish equivalent element nodal forces. Okay, remember that this is Q naught. This is Q naught, and we use small letter because this is for element. This is for element. This one is K. Small letter as well because this is for element. Okay, we use small letter for element and we use the capital letter for the structure. So same with K1, K2 and K3, we will have Q naught 1, Q naught 2 and Q naught 3 with the same degree of freedom label. Okay, so let's do it for Q naught right now. Okay, so now we want to calculate Q naught 1, Q naught 2 and Q naught 3. So we need to refer back to the main diagram. We need to refer back to the main diagram. So in the main diagram, okay, for AB is a member with vertical load is subjected at the center of member AB. So for this one, so we need to have this at the center 200 kilonewton, and to calculate the fixed end action, so we have the vertical reaction as well as fixed end moment. Fixed end moment for the vertical reaction is P over 2. It is 100 and 100 kilonewton, and for the fixed end moment is PL over 8. And PL over 8 is P is 200 times L is 4 divided by 8. The value is 100 and 100. So what we need to do is we have to sketch okay, YZ, it is 4, 5, 6, 1. 4, 5, 6, 1 because this is the near, this is the far end. Okay, so by comparing this, we need to put the value. Okay, we do it one by one. Okay, for position number 4. Position number 4 is 100. For position number 4. Position number 4. So position number 4, 100 positive. Position number 5, same direction, it is 100. Position number 6 also 100. And position number 1 in opposite direction, so this one we need to put negative. Okay, negative. Okay, this is Q naught 1. Okay, now I want to continue with element number 2 or member BC. Element number 2, the beam is the element or the member is subjected to a uniformly distributed load. Okay, so we will draw the diagram. It is UDL 25 5 meter. The fixed end moment acting like this, the vertical reaction acting like this. Okay, so based on the formula, for the vertical reaction, it is WL over 2. 25 times 5 divided by 2, we get 62.5, 62.5. And for the fixed end moment, it is 25 times L squared divided by 12. So it is 52.08, 52.08. And we need to compare with this. For element number 2, 6172. 6172. Okay, so we compare just like what we have done just now. Okay, for position 6 is the vertical value, vertical reaction at near end, it is 62. 62. 62.5. 62.5. Continue with, okay, 6 1 is moment 52.08. 7 is vertical value is 62.5. and 2 is moment in opposite direction, so we must put negative 52.08. 52.08. Okay, so we continue to calculate the value for element number 3, for Q03. Q03, so we sketch the diagram first. The loading is 150. So here is 150, 3 meter, 2 meter. Okay, so for the vertical value and for the moment. Okay, we check the formula. Okay, so we will put the value of Q naught 3. Q naught 3, it is position number 7. Position number 7 is 52.8. 52.8. 52.8. Position number 2 is moment. Moment is 72. Position number 8 is 90. 90. Position number 8 is 97.2. And position number 3 is negative 108. 108. Okay. So now we have established element global stiffness matrices and equivalent element nodal forces. Okay, with this we will continue to establish the stiffness equation to calculate the unknown displacement. So now we will continue with establish stiffness equation corresponding to unconstrained degree of freedom system. So I want to show to you now. We will only write the stiffness equation only considering unconstrained system, because the unknown displacement or non-zero degree of freedom is actually in unconstrained system only. So you don't need to write in full equation unless the question asks you to do so. So now we are looking at this. So refer back to, so this label is very very important, because okay, we want to fill in the equation just now. We will focus on position 1 to 3 in the unconstrained system only, so now we will put the value of Q1, Q2 and Q3 inside the equation. Q1, Q2 and Q3. Q1, Q2 and Q3. Q1, Q2 and Q3. So Q1, Q2 and Q3 is Q1 is the moment at B, Q2 is moment at C, Q3 is moment at D. Okay, Q1 is moment at B, Q2 moment at C, Q3 moment at D. So we just have to refer back to the main diagram. So there is no moment at applied moment at B, there is no applied moment at C, but at D there is an applied moment of magnitude 300 kN per meter clockwise direction, opposite with the sign convention, so it is negative 300. So the value that we need to put here for Q1, Q2 and Q3 is 0, 0, 0, 0, negative 300. So we put 0, 0 as well as negative 300. Negative 300. Okay, so next is K in terms of EI. So we need to put the value for position 1, 1, 1, 2, 1, 3, 1, 1, 1, 2, 1, 3, 1, 1, 1, 2, 1, 3, and then 2, 1, 2, 2, 2, 3, and 3, 1, 3, 2, 3, 3. So 1, 1, we will get the value. Okay, 1, 1. So we want to find the value right now. So it is 6172. 1 means this one 0.8, 0.8, 1, 1. It is 4561, 4561. So 1, 1 means this is 1, 1, 1. Okay, 1 plus 0.8 is 1.8. So we put 1.8 for 1, 1, 1.8. 1.8. So for position 1, 2, for position 1, 2, okay, position 1, 2, where is 1, 2? 1, 2 in K2, there is a 1, 2, 1, 2, 2, 1 is the same, 1, 2, 2, 1. 1, 2, 2, 1, 0.4. 0.4. 0.4. So the value inside this is 0.4. For 1, 2 is 0.4. For 2, 1 as well, it is 0.4. 0.4. 0.4. Okay, 0.4. And next is 1331. 1331. 1331. So let's find where is the 1331. 13, 13, 13, 13. No 13 inside K1, K2 and K3. So the value is 0. The value is 0 for 13, 0 for 31. Okay, next is 22. 22. Next is 22. Next is 22. Okay, we find 22. So where is 22? 22, 0.8 here, 0.8 and 22, 7, 7283, 7283. So 22 in K3 is 0.8. 0.8 and 0.8. So it is 1.6. 22 is 1.6. 1.6. 22 is 1.6. 22 is 1.6. So next is 23. 23. We will find where is 23. 23. Where is 23? So we look at K1. There is no 23. We look at K2. There is no 23. We look at K3. 23. So 23 or 32. 23. 2 and 3 is 0.4. 2, 3, 3, 2. 0.4. So we put 0.4 and 0.4. Okay, next is 3, 3. You find what is the value of 3, 3. There is no 3, 3 in K1. There is no 3, 3 in K2. And in 3, 3, 3 in K3 is equal to 0.8. 0.8. 0.8. So we put 0.8. 0.8. 0.8. Alright. So next, KD. This is K. So the next one is D. So D is unknown. D is unknown displacement. In this case, D is unknown rotation because it is occurred at support at roller support for B, C, and D. So we have to put as symbol first because this is the output that we need to determine. D1, D2, and D3. D1, D2, and D3 is also known. This unknown displacement is also known as unknown rotation. Is also known as non-zero degree of freedom. So we need to put D, D1, D2, and D3. So this is D1, D2, as well as D3. D1, D2, and D3. Okay, so for the degree of freedom, we only consider 1, 2, 3. This is just the label for the degree of freedom. Degree of freedom in unconstrained system. Okay, next plus Q naught. Plus Q naught means Q naught at position 1, at position 2, and at position 3. Q naught at position 1, at position 2, and at position 3. Q naught at position 1, position 2, and position 3. So we will find the value of Q1, Q naught at position 1, at position 2, and at position 3. So at position 1, it is negative 100. At position 1, we also have 52.08. 52.08. It is negative 100. It is negative 100 plus 52.08, we get negative 47 point, negative 47. It is negative 47.92. 47.92 Then the next one is position number 2. Position number 2 is negative 52.08 and 72. It is negative 52.08 plus 72. It is 19.92. And for position number 3, there is no 3 in Q01, Q02. So 3 is only located in Q03. It is negative 108. It is negative 108. So this is actually the stiffness equation. So this is the stiffness equation corresponding to unconstrained degree of freedom system. Okay, we only establish this unless the question asks you to write in full stiffness equation. But if the question asks you only to determine the unknown displacement or unknown rotation or non-zero degree of freedom, you need to establish up to degree of freedom in unconstrained system. So we have this. Once we have this, by solving this equation, we will get the unknown displacement. We will calculate unknown displacement. The unknown displacement. Okay, by just solving this equation. Okay, you don't have to rewrite it back into 3 simultaneous equation. What I want you to do is you need to directly key in the value into calculator and then give the D1, D2, D3. D1, D2, D3. Okay, and this is rotation, and remember the rotation, the unit is in radian. So you need to put the unit in radian. So to solve this, what we need to do is we have to simplify this equation first. Okay, we have to bring the Q and Q0 at one side. Alright, so it is 0 plus 47.92. It is equal to 47, positive 47.92. Positive 47.92. Alright, 0 minus 19.92. It is negative 19.92. And negative 300 plus 108. Negative 300. Negative bring to the other side. It is negative 300 plus 108. So we get negative 192. Negative. It is negative 192. Alright. So in this case, if the EI is given, so you need to consider EI, and then you will get the answer in unit radian. If EI is not given, suggest you can just leave the answer in terms of EI. So let's say EI is given. So let's say E is equal to 200 GPA, and I is equal to 600. Let's say I is 600 times 10 power of 6 mm 4. 10 power of 6 mm4. So EI is equal to 200 times 600 times 10. Okay, it is a 6 200 times 200 GPA is 200 times 10 power of 6, 200 power of 6 kilo. We don't need to change into Pascal, to change into Newton per meter square, because we have to remain the unit kilonewton, so we have to change it to 10 power of 6. So 6, and then another 6. So wait, I want to write in superscript mode. Okay, Okay, so now we have solved until unknown displacement. So I want you to do like this. Whenever you want, you solve whatever example or whatever problem, whatever question using stiffness matrix method. I want you to skip unnecessary step. Just focus on what is important in order to get the output for the analysis. So for this diagram, for this question again, for this question we have beam. We have beam with three elements. Member AB, member BC, and member CD with various types of loading. So of course, step number one, you need to put the degree of freedom. Remember to put the degree of freedom according to unconstrained and constrained system. So remember that the outcome, the output, the objective, the goal that we need to determine is the degree, the non-zero degree of freedom or the unknown displacement, and in order to determine that value, so we need to do all these steps. Step number one, we need to establish element global stiffness matrices K1, K2, K3, as well as equivalent element nodal forces. So what I do it here, since the label for K for element stiffness matrices and the label for equivalent element nodal forces are the same, so I put it in this way. Okay, so we need to label the degree of freedom for each element. This is a very important step. You cannot skip this step because this is the most important part in the analysis. So we will label according to near and far end for each element. So we will label the first two for the near end and the last two is for the far end. And inside each nodes, there are 2 degree of freedom in Y and Z direction because this is frame. So we need to label YZ. Okay, so all this is okay. K1, K2, K3 as well as Q01, Q02, Q03. Remember that Q0 is actually the whatever member, whatever loading subjected on the member, we need to classify as equivalent element nodal forces. Okay, Q0 is equivalent nodal forces for the structure. Okay, so this is different with nodal forces because nodal forces is actually what moment and forces subjected directly at nodes. And normally in beam we will have Q0 which come from the triangular load, the UDL or point load on top of the member. So we will determine all this, and after that we need to establish the stiffness equation because we will solve for the unknown displacement by analyzing stiffness equation, but we don't need to write in full. Because in full we only write in full when we want to when the question asks you to do so. Means the question asks you like this: establish stiffness equation, full stop. Then you need to give in full. But by looking at this question, you are asked to determine directly the unknown displacement, so you can skip that step, that procedure, and straight away you can only write the stiffness equation corresponding to unconstrained degree of freedom system. So it is Q plus Q is equal to Q0 plus Q is equal to KD plus Q0. Q is equal to KD plus Q0. So we have to find the value. So the position that we need, the degree of freedom position that we need to consider is at position 1, 2 and 3. So we will find the value Q at 1, 2, 3, D at 1, 2, 3, Q0 is also at 1, 2, 3. So we calculate. So remember that EI, the K is in terms of EI first. If EI is given, then you need to consider EI in the calculation because at the end you will get the unknown displacement in unit EI, in unit radian. So remember to change the unit correctly. So for E, you need to change it to 600 exponent 6. Cannot be exponent 9. It cannot be exponent 9 because exponent 9 represent Pascal. Pascal is in Newton per meter square. We need to remain the unit in kilopascal. Kilopascal, so we use exponent 6. And I is 600 times 600 exponent 6. 600 exponent 6. So we change it to and I is given in millimeter power of 4. So we need to calculate EI first. Is 10 exponent 6, exponent 6, exponent C, and exponent negative 12. So this will produce a 10 exponent 0. It is exponent 0, 10 power of 0, so it is equal to 1. So it is EI is equal to 200 times 600. 200 times 600. So if I want to consider 200 times 600 into the stiffness equation, okay, I can rewrite it back. The equation, I can rewrite it back. And after that, then I key in the value into calculator. And key in the value into calculator. Please do not write in 3 simultaneous equation. You just wasting your time by doing so. So straight away key in the value into calculator. Remember that the A1 is actually 216000, not 47.92, equal to D. The equation, the format in the calculator, you must know it is equal to D. So the first value that you need to key in into calculator is 216000, then 48000, then 0, then 47.92 until the end, negative 192. And then you will get the answer given by calculator. It is 0.000129 radian for D1. For D1 means that this is the rotation at position 1, at position B. D2 is 0.000416, and D3 is negative 0.0221. 0.00221 radian. Okay, this is how we analyze unknown displacement. Without considering support settlement. This is without considering support settlement. Okay, now when we need to consider support settlement, what we need to do? Of course, by considering the support settlement, we will get different unknown displacement, different displacement. Support settlement will give different displacement, different reaction. So how to do so? Okay, let's look at what happened next. Okay, so now we want to continue by considering support settlement. Okay, I want to look at back to the question. So let's say support C has a support settlement. C has settled. Let's say C has settled downward. Of course, settle downward of 20 mm. So now I want to show to you how we want to consider the support settlement. In the analysis. So considering support settlement. Okay, now we want to consider the support settlement. Considering support settlement. Support C has settled by 25 mm. Support C has settled by 25 mm. So again, C, please find the position of degree of freedom at support C. So what is the numbering? What is the degree of freedom position? Okay, settle at C, support C, settle downward means delta at C is equal to 25 mm. 25 mm, so we need to look at back to the we need to look at to the main diagram. Okay, settlement at C. Please look at this diagram at C. Settlement means this. Okay, settlement means Y, in Y direction. In Y direction, the label is 7. The label is 7 means that due to settlement, support settlement, since delta C has settled by 25 mm, so we need to consider D7. D7 is not equal to D7 will be equal to D7 equal to settlement downward opposite with this sign convention, so we have to put negative. Settlement downward but sign convention is upward, so it is negative 0.025. so this is 0.025. Negative 0.025 means that D7 is now 0.025. Not zero anymore. So this is in unit meter. So now I want to show to you how we are going to include this support settlement effect into the solution. So we will get the new value of unknown displacement. Due to the support settlement. So we move back to the equation. So what is actually occur? Okay. It means that we need to consider the displacement at position number 7. Of course, you need to have this in your mind. It is actually like this. Okay, in total we have the full equation is like this. This is the full equation. This is for D. This is for Q naught. So this is Q nodal forces. This is K. The structure stiffness matrix in full means 8x8 matrix. So this is in full. So anyway, you don't have to write in full. But if you think that you are not if without this full stiffness equation, you cannot understand, you cannot proceed with the solution considering support settlement. So you have to write in full. Okay, so QK, this is D, KD and Q naught. Q is equal to KD plus Q naught. So due to unconstrained system, we have this. This is 1, 2, 3 in unconstrained. Okay, and this is 1, 2, 3, right? This is for 1, 2, and 3. So we have for the displacement, we have D1, D2, D3, and we have D7 equal to negative 0.0025. So D4 is 0, 4, 0, 5, 0, 6, 0, 0, 7, negative 0.025. 0.025 here. Negative 0.025. Negative 0.025, and at position 8 again 0. So we need to put at the DOF position, which is the same position with the support that has the settlement effect. The settlement effect. Okay, so this one, okay. So to answer this question, actually we must we must understand the characteristic in matrix multiplication. It is line times row, right? Line times row. So we need to focus on the position 1 to 3 as well as position number 7. Position number 7 here. So we need to have the value for position number 7. The value for position number 7 here. If we have determined K at position K at position 1 to 1 1 1 2 1 3 1 1 1 2 1 3 1 2 3 1 1 1 2 1 3, but we need to have another value that we have to put at position number 7, at row number 7. Okay, 1 1 1 2 1 1 1 2 1 3 1 7. So please find what is the value for 1 7. So 1 7, we must look at back to K1, K2 and K3. Find the 1 7. Find where is 1 7. 1 7 in K1, no. 1 7 in K2. 1 7 7 1. 1 7 7 1 here. 1 7 7 1. Okay, it is negative 0.24. So we need to put negative 0.24 here. Negative 0.24. We have to put it here. Negative 0.24. Negative 0.24. Negative 0.24. 1 7. 1 7. So we have to continue with 2 7. 2 7. We have to continue with 2 7. We have to continue to calculate 2 7, the value at 2 7 position. There is no 2 7 in K1, 2 7 in K2, 2 7 in K2. Where is 2 7 in K2? 2 7 7 2 is the same. 2 7 7 2 is negative 0.24. Negative 0.24, 2 7 7 2. And we find another one in K3, 2 7 7 2, 2 7 7 2. 2772, it is negative 0.24, negative 0.24 plus 0.24. The value is 0. The value is 0. So yang ni, this one, okay, the value is 0. The value is 0. Okay, next value that we want to have is 37. 1 7, 2 7 and 3 7. 1 7, 2 7 and 3 7. Okay, 3 7. 3 7. Okay, find the 3 7 value. Okay, we must refer back to K1, K2 and K3. There's no 3 7 7 3 in K1. No 3 7 7 3 in K2. And we have 3 7 7 3 in K3. So what is the value? We check. Okay. 7 3 is 0.24. 7 3 3 7 is 0.24. So we have to put 0.24. This is 0.24. 0.24. 0.24. 0.24. 0.24. Alright. So the process is like this. The process is like this. We will has additional to this. We will actually just add additional value for considering the support settlement. So we will use the same equation that we have established previously. Okay, we will do this. We will use the same. We will use the same. We will use the same. Okay, we will use the same. Alright, we will use the same, but we have to add another value considering the support settlement. So I want to add it at the middle here. Okay, so I have to add the value I want to add the value considering support settlement. Considering the support settlement, we will have, by looking at this, so it is negative 0.24, it is negative 0.24 times negative 0.025. So it is negative, still in terms of EI here. No, I want to put EI. EI is 200 times 600. So it is EI 200. It is 200 times 600. Negative 0.24. Negative 0.24 times negative 0.025. So we get 720. Get this as 720. 720. The next value is 0. 27 is 0. 27 is 0. So the next value is 0. And the next one is 37. 37 is 0.24 times 0.24 times negative 0.025. So we will get negative 720. Negative 720. Negative 720. So these two value we have to add together. We have to add together. So this is considering the support settlement. Of course, later we will get different value. Actually, considering the support settlement, the solution is just a mathematical solution. If you understand the concept of matrix, then you know how to analyze this. Okay, it is not about structure analysis. It is about matrix. Okay, so it is 720. Okay, we want to simplify this. It is 0 minus 720. 0 minus it is 0 minus 720 plus 47.92. So we get negative 672.08. So I want to cancel this. Okay. So I will put directly the value here. Negative 672.08. 672.08. So we move to 0 minus 19.92 remain negative 19.92 and negative 300. Okay, it is negative 300 plus 720 plus 108. So we will get 528. So here we get 528. 528. So we have to solve this. Okay, solve this using calculator straight away. Key in the value, all the value, and then we will get the answer. Okay, we will get the new D, the new displacement. We get the new displacement. Alright, so we will key in the value right now. Okay, we have different equation, the new equation considering support settlement. So we use equation in calculator with 3 unknown. The first value that we need to key in is okay, I want to use this value, this one. After considering EI, EI is 200 times 600. So I need to put this. Okay. So the first value that we need to key in is 216000. Second value is 48000. Next value is 0. And D1 is negative 672.08. Okay, next value is 48000. And then 192000. And then 48000. Negative 19.92. Negative 19.92. A3 is 0. 48000. C3 is 96000. And last value is 528. So we get the new value of unknown rotation or non-zero degree of freedom. For D1, it is negative 0.00292. 0.00292. The value is negative. Okay, for D2, we get negative 0. It is also negative. Negative 0.000855. 0.000855. And last value D3. D3 last value is 0. It is positive value. Positive value 0.00593. 0.005 593. 0.00593. So by comparing this, and so we get this. Okay, this one is the value considering this is the displacement considering support settlement. Of course, we can make a conclusion or comparison for considering support settlement and without considering the support settlement. Okay, D1, this is for the answer, the non-zero degree of freedom considering support settlement, D1, D2 and D3. And of course, if we try to compare with the previous one without considering the support settlement, we found that the value is different. Means that the support settlement will contribute to the different value of displacement as well as reaction at the support. So I will stop this video right now. I believe after this we you know how to calculate the unknown reaction, after this. But the focus for this video is the comparison, how to analyze the unknown displacement, how to consider the support settlement effect. Without settlement effect, we only consider 1 to 3 position in the stiffness matrix, in the structure stiffness matrix. But when we have the settlement, we need to consider where is the position of the settlement. We need to consider. So since in this question, the position is at position 7, we need to check at position 7. So we need to have the value, the K value at position 1727 and 37, because this value will be times with the D7, and we will get like this. Okay, so it is just an additional to what we have done without considering support settlement. So I think that's all for this video. Inshallah, we will continue the next video in the next time. Thank you very much. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.